So good morning, everyone. I will start the webinar now. So welcome to this webinar about the use of a CTD-Diver in case of saltwater problems. My name is Marcel Lankreijer. I'm a trainer consultant at Eijkelkamp, and I will give this webinar today. I hope everyone can hear me. So the content of this webinar and the structure. First, I will give a brief introduction to saltwater problems. And then I will discuss measurement methods and how to apply them. At the end, I will discuss how the CTD-Diver can contribute to water research. So I will start this presentation, and if you have any questions, keep them until I have finished the presentation. You can ask your questions by writing them down in the dashboard, and after the presentation I will answer those, if they are there, of course. This webinar will take around half an hour, I think. So, salinization is a global environmental problem. It affects many different aspects of life by changing the chemical composition of natural water resources. Salinization leads to a decrease in the quality of surface water and groundwater, but also to the loss of fertile soil. Salinization is the increase in the total dissolved solids of an aquifer in water caused by natural or anthropogenic factors. The main problems are explained in this slide, in this picture, but we can summarize the salinization issues in saltwater intrusion, saltwater seepage, and also an issue which has to do with water but leads to salinization of soil. That's the third issue. The serious consequences of heavy groundwater withdrawal in coastal zones is that wells near the shore eventually draw salt groundwater. This is called saltwater intrusion. Because fresh water is less dense than salt water, fresh groundwater is like a lens floating on salt water. The pumping of the well will not only cause the water table to decline, but also has caused the interface between salt groundwater and fresh groundwater to move inland, as you can see on the right picture. The second saltwater issue is what we call saltwater seepage. It means low-lying areas, of course, like polders and reclaimed land are most affected by this. The drainage of these areas increases the seepage groundwater pressure from the deeper soil layers. This is one of the main causes of permanent high salt concentrations of the groundwater and surface water in those areas. Salinization of the soil occurs when the world's dry areas with the dry climates, soil is irrigated by a distribution system and allows water to infiltrate in the soil. The irrigated areas are subject to very heavy soil water losses through evaporation, and salts contained in the irrigation water remain in the soil and increase in concentration. Another working principle which contributes to salinization in soil is that by excessive irrigation, the groundwater level rises, more groundwater evaporates from the capillary zone, and leave salts behind in the soil. Areas of salinization show as white surfaces, and excessive salinity in soil leads to toxicity in crops, reduction in soil fertility, reduction of availability of water to plants by reducing the osmotic potential of the soil solution. And last one, a significant change in the hydraulic properties of the soil. Measuring methods. Well, the degree of salinization normally is investigated by determining the chloride content of the water or measuring the electrical conductivity, the EC. Determining the chloride content is mainly a lab analysis or can be done in situ in the field by measuring with a so-called ion-specific sensor. These sensors are not easy to handle and require specific care and high calibration frequency. Electrical conductivity is a measurement of the water's ability to conduct electricity and therefore is a measurement of the water's total ion concentration. And salinization is not only caused by chloride or one specific ion, and it can be a number of ions which contributes. The measurement of the EC value provides a good indication of salinity because when the amount of ion rises in a solution, also the EC value rises. With EC measurements, all soluted salts and water are measured, and not only chloride, for example. EC can be measured in the field with a simple small sensor. Well, how to apply and investigate? As I explained, the density of water depends on the concentration of salts. It means that in water, the salt content varies in depth. A method to identify the different zones with fresh water, saline water, and brackish water. This can be done by profiling. Profiling is a measurement of EC together and in relation to depth. In a surface water, this can be done by lowering a EC sensor in the water from surface down, or of course the other way around, from bottom to top. In groundwater, in a monitoring well, profiling like in surface water is only an option if the monitoring well pipe is provided with a very large screen in which the water can enter and flow horizontally along the total screen. This is explained in the right picture, monitoring well B. So the screen should extend over a great deal of the water-bearing layer. In those kind of wells, sometimes so-called packers are used with which you can isolate parts of the screen from the rest of it to make your measurements more accurate. It prevents mixing of water from different depths. If your monitoring well is an ordinary well, which has normally a screen of 1 meter or 2 meters, you must realize that your EC value is a measurement from a specific depth, in this case, the depth in which the water enters the monitoring well. This is shown at monitoring well A. Measuring or profiling in the blind section of the well pipe makes no sense because the water in the blind section is most of the times affected by air and is of less sample quality. The degree of salinization in soil is determined by a different method as it is not a determination in pure water. One of the sensors which can be used in soil moisture is a soil moisture sensor, which you can see over here. It's totally different, which can measure soil moisture, content as a volume, temperature, and also electrical conductivity. This is a different technique of measuring comparing to the ordinary EC sensors for water. Working with sensors give you data, so it means that you should do something about data reliability. The electrical conductivity depends on temperature. To compare results, the EC value needs to be corrected for temperature and expressed to a temperature of 25 degrees Celsius, or depending on the guideline which applies in the country, to 20 degrees Celsius. If the EC value is not compensated to temperature of 25 degrees, we are talking about true conductivity, and if conductivity is compensated, corrected, we are talking about specific conductivity. In order to obtain consistent results, every water quality sensor needs calibration. It is a very important part of successful water quality measurements. And this should be carried out regularly. It means for the EC sensor, checking the readings of the sensor on standards, and if needed, adjustment if reading deviates too much on standards. A very simple check to see if your sensor is working correctly in EC sensors should read 0 when it's not in the water and dry. If your depth measurements are performed by a pressure sensor, be sure this sensor gives you the correct data. The performance of a sensor must be checked by a manual measurement of the water level. A pressure sensor above the water should give you a pressure which is equal to air pressure. And secondly, it is good to realize that a pressure sensor is not the same as a measuring tape. It acts differently. All sensors do have offsets and can suffer from drift. Well, all the parameters which are important and which are described in the previous slides are possible in the application of a CTD-Diver. When there is a need to monitor groundwater levels and also saltwater intrusion, it is the instrument of choice. The CTD-Diver is a submersible data logger for long-term, uninterrupted or real-time water level monitoring using a pressure sensor submerged under the water surface. The pressure sensor measures the hydrostatic pressure of the water above the sensor to calculate the total water depth. And in addition to a pressure sensor, the CTD-Diver is also equipped with a sensor for measuring the true or the specific electrical conductivity of the water, and also is provided with a sensor to measure temperature. All parameters are stored in its internal memory. Well, it has a corrosion-proof ceramic housing, of course, to stand the saline conditions, and one measurement means a line with date, pressure value, temperature value, and an EC value. The diver can be programmed in a very short sample interval, 0.5 seconds, for example, is possible, and this makes the sensor very suitable for profiling. Of course, the sensor can also be programmed in different sample intervals for monitoring purposes, for example, one measurement per hour or one measurement per day, if you want to identify changes of the water quality in time. The diver can be programmed and data can be transported from the diver to the computer. In general, the software Diver Office is used for this. If your diver is connected to a telemetry system, there are also other methods to communicate with the diver, but this webinar is not about this subject. You can download Diver Office for free from the website, and in Diver Office there is the option to perform a calibration on EC. This can be a single point calibration, but also a multiple point calibration. Regarding calibration of the CTD-Diver, each CTD-Diver is factory calibrated for pressure, temperature, and conductivity. And for EC, if the deviation on EC is greater than the specified accuracy, it is recommended to recalibrate the CTD-Diver. And this possibility is there in Diver Office. The data cable. The diver, if it is programmed, can be connected to a rope, but it can also be connected to a data cable. With this cable, you can connect a diver with a modem and with a telemetry system. This system will sending you data from the diver, for example, every day. This is very useful for long-term monitoring, or for example, an early warning system. The diver measures and stores his data in his own logger. The data cable gives you, together with Diver Office, the possibility to look at the measurements in real time. So you have a diver in the water connected with a data cable, and the data cable connected to a computer with Diver Office. In Diver Office, after you have pressed the button for real-time measurements, you will see this screen that will give you the measurements that the diver is taking at that specific moment. Of course, that is only visible if the diver is programmed in high frequency. Otherwise, you have to wait a long time. So you can see, I hope you can see my mouse arrow. So the green line, that's the temperature. And the red line is the EC value. And apparently the diver is programmed for a specific conductivity. So the diver is measuring specific conductivity. The screen above gives you the pressure or the water table. And as I explained before, the diver is a sensor, and the sensor never gives you the same reading. It is not a measuring tape. So all the pressure sensor readings always deviate a bit. Of course, the diver stores all the readings, but this feature, the real-time measurements possibility, is very useful if you are profiling, for example, and if you want to see immediate results. In this slide, you will find some more technical specifications of the CTD-Diver. For example, the diameter of the diver. It is important to know for its application in monitoring wells. It is also important to know that there are 3 ranges available. And you can see it over here. This means the diver with 10-meter range is applicable in water with maximum 10 meters of water column above the sensor. And the diver with 50-meter range is applicable with a maximum of 50 meters of water column, and the last one 100 meters of water column. So these different types do have different accuracies, as you can see. And remark that the diver with the 10-meter range is the most accurate one. Regarding conductivity and the temperature, there are no differences between those 3 types. They all have the same accuracy for temperature and conductivity. So I'm getting to the end of this webinar. I hope I could explain what a CTD-Diver can mean in water investigation, especially when you are facing saltwater problems. If you are, after listening to this presentation, very interested in applying a CTD-Diver and are considering to purchase one, at the moment we offer the CTD-Diver with a discount, and our people from the sales department can tell you more about this offer, and please contact them in that case. If you want more information about, for example, prices and sales issues, please write an email to the sales department. Any other information can be found on the website, or ask us by sending us an email. On this slide, you will find several addresses for this. This is the end of my presentation.